This is lesson 5 in our 6th lesson unit on geometry on the coordinate plane, otherwise known as analytic geometry. The first thing we need to do is review the form of the equation of a line. And there are two forms that we are going to review, point-slope form and slope-intercept form. Also, just a reminder that a vertical line has the form x equals a number, and that a horizontal line has the form y equals a number. The slope-intercept form of a line is y equals mx plus b, where m is the slope and b is the y-intercept, the place where the line crosses the y-axis. For example, if I have y equals negative 1/2 x plus 5, my slope is negative 1/2. Don't forget that the slope is just the number, not with the variable, and the y-intercept is positive 5. There are two ways you may have learned point-slope form in Algebra 1. If you learned it at the high school, you learned y equals slope times x minus x1 plus y1. And if you learned it somewhere else, you may have learned that you can do y minus y1 equals slope times x minus x1. Notice that the only difference between these formats is that here we are adding y1 onto the right, and here we are subtracting y1 on the left, which is equivalent. So you can use either form, but I will stay in this point-slope form with the y equals isolated or by itself on the left. Again, m represents slope, and x1, y1 is a known point on the line. For example, in this equation here, again, we have our m, slope is 3, and the point that I know on the line is x1, y1. So we need to be careful with the signs here. If it's x minus x1, then x1 is positive 5. And if it's plus y1, that means that it's plus negative 2. So our y value is negative 2. So if I were going to sketch this line, it would be through the point 5, negative 2, and have a slope of positive 3. We are often given lines that are not in either of these forms, which makes it a little bit trickier to find the slope and y-intercept. So the easiest way to find slope and y-intercept from a given equation is to rewrite the equation in y equals mx plus b form, because then our x coefficient tells us the slope and our constant tells us the y-intercept. So in my first example, I want to get y by itself. That means I need to subtract 7 from both sides. I get y equals x minus 7, and then I can identify the coefficient of x, my slope, is 1, and my y-intercept is negative 7. In my next example, I have slope of m here, but I don't know my y-intercept, so I am going to distribute my half and add 4 so that I have y equals slope x plus y-intercept. So my first step, I get y equals 1/2 x minus half of 7 is 3.5 plus 4. Combine my like terms, and I get 1/2 x plus 1/2. So now I can see that my slope is 1/2, and my y-intercept is also 1/2, or 0.5. In our next example, we have a few more things to move around. Again, my goal is to get y by itself on the left. So I want y equals something, x plus something. So I'm going to start by moving the 4 to the right and combining my like terms. I now have 3y equals 2x plus 12. And then to get y by itself, I need to divide everything by 3. So I have y equals on the left by itself now, the 3's cancel. I have 2/3 as my x coefficient, and I have 12 divided by 3 is 4 as my y-intercept. So 2/3 is my slope, and my y-intercept is 0.4. Finally, in my last example, I need to move my x term to the right. So I'm going to subtract 3x from both sides. You might remember that this actually is called standard form, something x plus something y equals a number. But for finding slope and intercept, that is not the most helpful form. So I'm subtracting 3x from both sides. And remember, I want y by itself, so I am dividing by 2. And I get y equals negative 3/2 x. And dividing 6 by 2, I get 3. So a slope of negative 3/2 and a y-intercept of 3. Now that we've reviewed the algebra of writing equations of lines, we are going to explore some geometric figures on the plane. So the first thing I'm asked to do is write the equation of a line that is parallel to L through the point 5, 3. Whenever we see the words through the point, that is my hint that I know x1, y1, so I might want to use point slope form. I'm going to write it both ways. You can choose which one you prefer. So I'm going through the point 5, 3. I always like to draw a sketch. And if I want to be parallel to L, that means I need the same slope. So I'm going to need to figure out the slope of line L. I'm going to use rise over run here. So down 1 over 2. My slope is negative 1/2. My x1 is 5 and my y1 is 3. So I have y equals negative 1/2 times x minus 5 plus 3. And that is this line here, parallel to L. Next, we're going to write an equation of a line through the origin perpendicular to L. Remember, perpendicular means that I want the opposite reciprocal slope to the slope of L. So I'm going to take the negative 1/2. I'm going to switch the numerator and the denominator, and I'm going to change the sign from negative to positive. So my slope is going to be positive 2 wholes, or just positive 2. The origin is the point 0, 0, which means I know my y-intercept is 0. Because I know the y-intercept, I'm going to choose slope-intercept form. So here's my b value, here's my m value, and my equation is y equals 2x plus 0, or just y equals 2x is the way that you will generally see that written. Additionally, just to make sure that my equation makes sense, I'm going to graph that line and make sure that it looks parallel to my red line. So y-intercept of 0 and a slope of 2. And when I sketch that line, it definitely looks perpendicular to line L. In this next example, we are looking for the altitude from point A in triangle ABC. So remember, altitude means that it is perpendicular to the base, and if it's the altitude from A, then we're making it perpendicular to BC. So I'm just going to sketch the altitude here so I have an idea of the kind of line I'm looking for. I notice that this point is on the line. That's the point 0, 2. So I know that I have the b value of the equation. And I need now the slope of this blue line. But I don't have another point to go to, so I'm not sure what the slope is using rise over run. However, I do know that it has to be perpendicular to BC. So that's the trick I'm going to use to find the slope. I'm going to find the slope of BC and then use the opposite reciprocal. So the slope of BC goes from B to C. That's a down 4 and right 1. So the slope of BC is negative 4 over 1, or just negative 4. That means that the slope of a perpendicular line will have a positive slope to be opposite, and we'll take the 4 over 1 and flip it to 1/4. So I now have my slope and I have my y-intercept, and I'm ready to write my equation. Y equals a slope of 1/4 x plus my y-intercept of 2. And I should probably just double check that that makes sense if I draw that entire line. So I have a y-intercept of 2 and a slope of up 1/4. That looks like it's going to be perpendicular to that base of BC. In our next example, we're just doing a quick reminder of what a horizontal and a vertical line look like. So if I'm going through the point -4, 8, that means that a horizontal line would have a 0 slope and would look like this. And all horizontal lines has the form y equals whatever the y value is. The y value of this point is 8. So my equation is y equals 8. For a vertical line, I am talking about every point on this line having the same x value. So the equation of the vertical line is x equals the x value of -4. And for our final example, we are going to write the equations of the diagonals of a parallelogram. So I've sketched the parallelogram in blue and the diagonals in red and green, and I'm going to find those equations respectively. So the red diagonal goes from the point -1, 5 to the point 2, -3. So that means that I need to find the slope and either the y-intercept or choose a point. I'm going to choose a point because I don't see the y-intercept clearly. So my slope is going to be down from 5 to -3, that's down 8, and over from -1 to 2, that's 3. So my slope is -8/3, and I'm just going to pick one of my points. I'm going to choose -1, 5. I could just as easily have chosen 2, -3. So my equation for my red line is y equals -8/3 x plus 1, because it's minus x1, minus -1, and then plus 5. If I wanted to write this in slope-intercept form, I would get -8/3 x, and then minus 8/3 plus 5. 5 is the same as 15/3, so when I combine like terms, I get y equals -8/3 x, minus 8/3 plus 15/3 is plus 7/3, which is a little bit more than 2, which is exactly where I cross the y-axis. So I am very confident that this is the equation of my red line. Let's try the green line now. For the green line, I again need points and slope. So my points are 3, 5, and -2, 3. That means I'm going up 8 in the vertical direction and over from -2 to 3, 5. So my slope is 8/5. My point, since I'm not really sure, it looks like it might go through 0, 0, but I'm not totally sure about that. I'm going to use the point -2, -3. So I have y equals my slope of 8/5 times x plus 2 minus 3. And now I'm just going to distribute and write this in y-intercept form so that I can verify that the y-intercept seems to be approximately in the right spot. So 8/5 of x, twice 8/5 is 16/5 minus 3. 3 is equivalent to 15/5. So I have y equals 8/5 x plus 16/5 minus 15/5 is 1/5. So that's close to 0, but not the same. So it's a good thing I didn't use 0, 0 as my y-intercept. That would have given me an incorrect value. So now that we've talked about how to write the equation of a line, how to find the slope and y-intercept of a line from any form, and how to apply that to solving problems involving geometric figures on the coordinate plane, you guys are ready for some practice.